emission control. So when you talk about emission control, ideally we are talking about interventions that are put in place to make sure that the internal combustion engine does not pollute the environment. So when you talk about emissions in vehicles, what are these types of emissions that you're talking about? So the internal combustion engine ideally breaks down the petrol or the fuel by the process of combustion. So we are burning petrol in the presence of air to get heat or liberate heat, and as a result we're getting other byproducts like water, carbon dioxide. But then there is unburnt fuel one. Not all the fuel burns, so we get one of the byproducts being as hydrocarbons, and these are actually harmful to the environment because one, they damage the ozone layer, and they create smog. Secondly, you realize that in the air there is a lot of nitrogen, or rather air is comprises of about 79% of nitrogen, whereas 21% is the oxygen that now we use to combat. So oxides of nitrogen are also created, especially when there is high heat or when the engine is burning a lean mixture. Oxides of nitrogen are very irritant to the eyes, and they also damage the environment, or they cause pollution. Thirdly, we have carbon monoxide. So carbon monoxide again is an invisible gas and is as a result of incomplete combustion. Lastly, we have particulate, and these actually soot particles that actually come from either fuel additives, and these are the sulfur that are used to purify the diesel, and in some cases when you used to use lead to purify the petrol. Diesel vehicles are also not known to create some sort of soot in the form of particulate, which you're also going to see how it's removed. So we have various maybe we ask ourselves, which of the following is not a major component of harmful exhaust emissions? Of course, carbon dioxide is not very harmful. Yes, the creation of carbon dioxide will cause an increase in ambient temperature of the earth. However, the gas is not harmful as say. Now we have several emission control systems that are used in modern vehicles. Now you realize that the modern vehicle or the modern engine keeps on changing or improving rapidly with technology, and as far as engine management systems are concerned, actually the main drive of these improvements is to reduce emissions, and emissions are what are driving every car manufacturer to try and create a more efficient engine. So engines are growing actually smaller, more powerful, with more intentional electronic controls management engine management systems that are geared towards adjusting the combustion process. But however, even with the best engine management systems, you realize that there's still some emissions control. Like I was saying, that you realize that when we burn a rich mixture, there is a likelihood of getting more hydrocarbons in the emissions, and more carbon monoxide as well, and particulate matter. While on the other hand, when you run a lean mixture, the engine or the combustion temperatures become very high, and therefore you get more nitrous oxides. So we have several methods that are used to control emissions, and these ones include: one, we have a catalytic converter; two, we have air injection systems; three, we have exhaust gas recirculation system, or what we call the EGR. We also have evaporative emission control, or the EVAP system, and we have positive crankcase ventilations. Now one method is missing here that we call the diesel particulate filter, ideally specifically made for the diesel engine. Now let us look at one of each of these methods. So when we talk about the catalytic converter, uh, uh, catalysis or catalyzing is actually trying to speed up a process. So the catalytic converter is an intervention that is done after the process of combustion, way down the exhaust, and we actually call it an after treatment. So we're trying to treat the exhaust gases as they leave the engine by introducing this catalytic converter. So a catalytic converter has two chemical reactions, one being an oxidation converter and the other one being a reduction converter. Now, inside the catalytic converter, as you can see here, we have the metal case of the catalytic converter, and inside it is actually a honeycomb made from a ceramic material, but then the two of them are coated with minerals, rich in minerals that are either the reduction catalyst or the oxidation catalyst. So where we have the oxidation catalyst, the minerals are actually platinum and palladium, and where we have reduction converter or the catalyst, we have the rhodium in its place. So what we have here is actually what we call a three-way catalyst, because it is actually able to do about three functions. So the air comes in from the left, moving towards the right, and the first catalyst that we find here is the reduction catalyst. Now, the reduction catalyst actually reduces oxides of nitrogen or whatever is in oxides. So it breaks down the nitrogen from the nitrous oxides into nitrogen and oxygen, and therefore releasing it as less harmful gases, because we only get oxygen and nitrogen, which are not harmful. Then the other part of the oxidation catalyzer actually oxidizes the hydrocarbon here and the carbon monoxide. So when you add oxygen to hydrocarbon and CO, you get H2O and CO2, and similarly here you get H2O and CO2, making them to be less harmful gases. So when talking about the catalysis, it actually means that there is also the presence of heat, or these reactions are actually dependent on the presence of heat. So conversion temperatures will occur between 900 degrees centigrade or somewhere around there, and it means that the catalyst actually starts to work out once the engine has warmed up. So it's actually dependent on the exhaust gases coming down through it, heating it up, and then creating the temperature that's sufficient to do these reactions. So the third part is actually the control, which tries to control and measure the output. So most of the time you find a lambda sensor fitted to the last part of the catalyst to monitor and see how much oxygen or the oxygen levels that are being found in the exhaust, so that you can send a feedback back to the ECU. So we ask ourselves, what does this simple mean? And I'm sure it's pretty simple, that is water. Method number 2 is the air injection system. And air injection system actually aims at introducing fresh air into the exhaust stream, ideally to try and reduce these pollutants that is exhaust. So we have an air pump, we can see here, driven by the belt from an engine, and the air pump blows air into the exhaust, and this air helps to burn the excess hydrocarbons, because there is already heat. We already have above 900 degrees in the exhaust, so when we introduce air, the fuel in the exhaust will continue burning as long as there is a presence of air. So the air pump will actually introduce air via injection into the manifold. Then we also have a diverter valve that helps to store air when the vehicle is decelerating, and of course we want to have a check valve that allows for air to move in one way, so that the hot exhaust gases do not come back into the air hose. So this is one of the methods that is used, and you can find this on some earlier models, the Mercedes, like the 271 engines and so on, and you'll find actually an additional air pump blowing air into the exhaust. So again, which part stops the air from coming back to the exhaust valve? That means it's the check valve C. Then we have the EGR, which is the exhaust gas recirculation. So the main aim of the EGR is to reduce the nitrous oxides. And ideally, we talked about the nitrous oxides are formed when we have exhaust temperatures running high. Or rather, combustion temperatures, when they go high, that is when we get the presence of the nitrous oxides. So we actually try to reduce the combustion temperatures by polluting the air that is coming in. And how do we pollute it? We actually introduce inert exhaust gases into the inlet manifold, and therefore we lower the combustion temperatures. So this EGR valve can be either actuated through a vacuum or can be actuated through an electronic actuator from the ECU. So what we have here is actually an EGR valve with a diaphragm that's actuated by a vacuum. Of course, this looks like a manual mechanism that does not have an ECU, but then it's dependent on a temperature switch. So when the temperatures of the exhausts are high, or the combustion temperatures run high, this switch is open and allows for vacuum, depression to be sucked, or the depression from the manifold to go through the switch and to suck onto the diaphragm, therefore pulling this valve up to allow exhaust gases to flow from this direction. And you can see the black exhaust gases, and as they mix with the passing airstream, and therefore dilute the gases and therefore lower the combustion temperatures. So other methods are if this valve is actually actuated by electronic control using a stepper motor, so that it can open in stages and then bring down the exhaust temperatures. So again, what is the main cause of oxides of nitrogen being produced in a vehicle exhaust system? It is high temperatures. The other method, or rather what we also see in electronic EGR components, like you can see here, we have our EGR valve actuated by the ECU through this solenoid. The solenoid allows for vacuum to flow to the EGR valve and blow it out. And then we have a differential pressure sensor providing feedback confirmation that the EGR is operating. Now, I wish not to go into details about the electrical system, but once we visit the workshop, we'll try and identify these components. So nowadays, you'll actually find vehicles having a cooler because the exhaust gases are pretty hot, and before they're introduced into the manifold, into the intake manifold, the exhaust gases are cooled down slightly so that they cannot also affect the temperature of the gas. Then we have electronic evaporative emission control. So when you store fuel inside a container, in this case a fuel tank, it produces vapors. In older vehicles, the tanks usually were vented and they would allow the vapor to be free into the atmosphere. And these are actually the hydrocarbons that are released to the atmosphere that then would cause pollution and a lot of irritation to the eyes and the respiratory system. Modern vehicles now are sealed, where you have a tank with an air dome for allowing vapor and expansion. But then this vent line collects all the vapor of the fuel and stores it into a charcoal canister, waiting for actuation and then to allow the vapors to flow back to the engine. Now, if we look at this diagram here, it shows an electronic evaporative emission control. So we have our fuel tank on this end, and our tank is not vented, so it does not allow for vapor to leave. However, the vapor is picked up through a vent line, and we have a roller of a valve or vapor separator that stops any fluid from passing through here. Even if the vehicle overturns, nothing or no fluid can go past here. So this vapor is then collected inside this container. It's usually a plastic housing, but inside it has activated charcoal, and it stores the fuel vapor here, waiting for it to be discharged. Now, once the purge valve is triggered by the ECU, it allows for the valve to open, and the vapor flows into the stream of air going to the engine, where then it is burned. So the vacuum line here is the one that is triggered, or is the one that is used to draw vacuum up from the manifold to open the valve. So in the electronic evaporative emissions control system, where does the vapor end up being vented? Well, into the inlet manifold. Then we have positive crankcase ventilation. Now, when the engine is running, there is always a small amount of gases, and especially the combustion gases, that go past the small ring grooves and the gaps and end up in the crankcase. Now, in older vehicles, usually there used to be a breather that was hanging under the engine, especially in commercial vehicles, that would allow these gases to escape into the atmosphere. Now, these gases, of course, contain hydrocarbons because they have unburned fuels and byproducts of the combustion process, which also have some pollutants. Now, in modern vehicles, a positive crankcase valve has been introduced that allows any gases that are being drawn past the blow-by to be recycled and taken back to the engine to be burned. So as you can see, here we have a scenario of a V engine where one bank has a vent from the air cleaner, allowing for air to pass through, and this allows for venting of the gas from the blow-by to circulate and go through the PCV valve and enter the manifold where it is burned. So it is the fresh air which mixes the blow-by gases in the crankcase to dilute them and flush out these gases out. So this air that flows in through the top crankcase flows through the drillings that allow oil to go to the crankcase, and it mixes the blow-by gases, allowing for the circulation of air to go around, and therefore stopping any form of emission. So where does blow-by occur? Again, it is past the piston rings. So this is what a PCV valve looks like, and you can see this valve attached to any top cover of any petrol or gasoline engine, and even some diesel engine will have this, but actually it tries to take all gases that are from the crankcase back to be burnt and not into the atmosphere. So you can see here the spring of the valve that is shut when the engine is off. At idle, maximum vacuum defeats the spring pressure and minimal crankcase vapor flows. At normal engine speeds, the plunger moves to central position and maximum vapor will flow. So what is the position of the plunger when the maximum vapor flows in a PCV valve? It is in the central position. So in summarily, we have looked at types of emissions and the emission control devices. Now I want us to look at the DPF valve in a few. Let me switch over to another slide. So we say that diesel vehicles actually produce particulate matter in the form of soot. Now, to reduce emissions in CI engines, other than methods like the catalytic converter and the EGR valve, we also have another method that is added that's called the particulate filter. And in this case, we call it the diesel particulate filter, or the DPF. Now, it looks similar to the catalytic converter from external, but inside it actually has a substrate material that has an oxidizing catalyst and a filter that traps and burns soot. So the oxidizing catalyst is actually targeting the soluble organic fraction of unburned fuel and oil, tries to oxidize it. So this kind of filters are actually fitted downstream after the catalytic converter, and their aim is actually to trap the soot that comes from the diesel engine. And once the soot accumulates inside this filter, and especially if it reaches a percentage of about 45%, it either notifies the driver or automatically initiates a regeneration process where the engine runs at a higher revolution and burning a richer mixture to create enough heat. Sometimes it creates enough heat to become red hot so that it burns any soot inside here to become ash and therefore clean up the filter. So there should be either two methods that can be used to regenerate the engine. It can be done intentionally by driving the vehicle over long distances at high speeds. For example, if you drive for 100 kilometers at speeds above 80 kilometers per hour, there is enough heat generated continuously that makes sure that your DPF clears up. Alternatively is to initiate a regeneration process at a service workshop, either by the touch of a button in the driver's cabin or by starting or launching the regeneration process by use of a scan tool or diagnostic tool. Now it is very important when doing the regeneration that you make sure that the vehicle is standing on dry ground without grass on it or any flammable material. Ideally concrete would be the best, because during the regeneration process the engine races at revs above 1500 revolutions per minute, introduces extra fuel into the exhaust stream, and actually burns the exhaust to become red hot, therefore clears any particulate matter. And with that, I think I come to the end of my short preview of emissions control. Kindly read the PDF notes that I sent to you for further clarification. Thank you and good evening.